responses so that it will be helpful for me to start the class. Dilip, Karthik, Kiran, Manju, Mitrunjay. Is my voice reaching to all? Okay. All right, guys. So I believe my screen is also visible to everyone.
This meeting is being recorded.
Okay. So I will go to this SQL. Okay, same. Today also we are discussing, okay, SQL. Okay, structured query language only. Today also we are discussing SQL. Okay, queries only. Fine. Today we'll see from joins. Okay, today we'll see from joins, the different types of joins that what we are having, that we'll see, okay, in our SQL query language. So this all we have seen, right? Select this thing, where, order by, and, or, not, insert, null, update, delete, all these things we have seen. Okay, joins. We have to start from joins today. Okay, what is this joins? We'll see. So see, guys, what is a join? I'll tell you simply. See, whenever we come we came across a requirement wherein, okay, fetch we have to fetch or we have to get the data. Whenever we came across a requirement wherein we have to fetch or we have to get the data from multiple tables, from multiple tables, then we use joins. Very simple definition I'm saying. And also, okay, in SQL we are having different types of joins. We're having different types of joins. What are the different types of joins we are having? Okay, we are having, inner join, left join, right join, okay, full join, cross join. We're having all these different types of joins. Okay, so what inner join will do? Inner join will give the common records from both the tables. Okay, it will give the common records from both the tables. Left join will give all the records. I'll show you from practically from the queries also. All the records from left hand side table, or first table. Okay, what left join is doing? It is giving all the records from left hand side table or first table, and common records from both the tables. Okay, fine. What is this one? Right join. It will give all the records from the right hand side table or second table, and common records from both the tables. Okay, what full join will do? Okay, it will give all the records from both the tables. All the records from both the tables. Okay, all the records. If this one table is having 10 records, one table is having 5 records, it will give you 5. Here, Inner join, it will give only the common records from both the tables. Left hand side will give the all the records from left hand side table, or first table, whatever the table we are writing first, that table, that will be considered as left hand side table. Okay, I'll show you practically also in the queries. Okay, just let me explain you theoretically, then we'll go for the queries also. We'll go for the queries implementation as well. Okay, how we are writing the queries. Okay, all right. So cross join, it will do the multiplication. It will do the multiplication, okay, of the existing records in both the tables. Example, if first table is having 5 records, other table is having 10 records, then it will give you what? 50 records. First table is having 5 records, second table is having 10 records, and it will do the multiplication, cross join. It will do the multiplication. 5 into 10, that is 50. It will give 50 records. It will give 50 records. Here, full join. One table is having 5 records. Okay, let's take 10 records, and other table is having some, okay, 8 records. Then it will give you total 18 records. Okay, right join all the records from the right hand side table or second table, and common records from both the tables. Common records from both the tables. Okay, all the records from the left hand side table or first table, and common records from both the tables. Okay, inner join is what? Common records from both the tables. There are different types of joins we are having in SQL. If you see here now, okay, a join clause is used to combine rows from two or more tables. Two or more tables based on a related column between them. Let's look a selection from the orders table. This is an orders table. Okay, this is a customers table. And always remember, guys, whenever we are writing a join in our SQL query, whenever we are writing a join in our SQL query, okay, you should always ensure that the tables what you are considering to join, the tables should have a common column, okay, among them. The table should have a common column, compulsory. Okay, whatever the tables that you are considering to write a join, the table should have a common column among them, and based upon that common column only we'll do the join. Based upon that common column only will do the join. Okay, so that common columns you should be know definitely. Okay, if you give a join on wrong columns, then you will get the wrong result. You will get the unexpected wrong results. Okay, this you have to keep in mind. So see here now, this is one orders table, this is customers table. What is common column between these two table? This is one table, this is another table. What is a common column between these two? Customer ID is the common column. The customer ID, customer ID. Customer ID is a common column between these two tables. So when I am writing a join condition for this table, orders table and customers table, I'll use customer ID column to join these two tables. See here, how can I say common column is there? See customer ID. Also see here data is what? 23777 213. Okay, data is also same to some extent. Data is also same. Okay, fine. This is compulsorily you have to check. Just don't go blindly. Something like, customer ID is in the above table. Customer ID is also here. And now I will go and I will start writing the join condition. No, join will not work like that. The data should also be the same. That is also important. Okay, that is also important here. So what I am saying, see here. Okay, if customer ID column is here and customer ID column is here, you blindly go and started writing the join condition. That is also not the case. Even if the column name is common, still you have to check the data also. Here numeric data is there. Numeric. Okay. Here numeric data is there, and here if it is characters data, like some names are there, like Smith, Martin, okay, Coco, then also you cannot make a join condition. Okay, data should also be the same, then only you have to make a join. Notice that the customer ID column in the orders table, okay, refers to the customer ID in the customers table. The relationship between the two tables above is the customer ID column. Then we can create the following SQL statement that contains an inner join that selects records that have matching values in both the tables. So what I'm doing here, see, select orders.order ID. Orders is what table name. This is the column name. Table. Okay. From, okay, orders, from orders table. Okay. First table, second table. Okay. Let me open SSMS here. Just 1 minute. Hold on. Connect to SSMS SQL server. See now, this is our first table. This is our second table. Or this will be our left table. This will be our right table. That's what I have written here. See, left join all the records from the left hand side table. So how should you know who is left hand side table, who is right hand side table? That's why I've written here first table. So this is our first table. So this will become our left hand side table. This is our second table. This will become our right hand side table. Left table, right table. Okay. From table 1 inner join table 2 on table 1 dot common column. Table 1 is what? This one, orders dot customer ID equal to table 2 customers, table 2 dot a common column. Now you can run the query. I'm not having these tables, orders and customers in my Narration database. That's why we are getting these errors. Okay, so what we'll do it here only. Okay, I'll say try it yourself. I say here run SQL. See now it is giving me these many are the records. Okay, which is common. Which these records are being fetched based upon the customer ID column in both the tables and which is common records. Okay. Getting guys, is that clear or not? These are the records. I got it based upon the inner join condition in which customer ID and customer ID is the common column and the common records are existing. That is what we are fetching here based upon the common customer ID column data. Based upon the customer ID column data. Okay, fine. So see here, I am getting this many. Okay, it is showing little only, but many records are there that we are getting across. The different types of SQL joins we are having, see here, different types of joins in SQL. I told already, inner join, left join, right join, full join, and cross join also I have told. Inner join, left join, right join, full join, cross join. Cross join they have not given, let it be. See, inner join, this is one table, first table, second table. This is first table, first circle, first table. This is second table. Getting the common records from both the tables. We are getting the common records from both the tables in inner join. Okay, then left join, all the records from the left hand side table and common records from both the tables. Same thing I have written here. See, all the records from left hand side table or first table, common records from both the tables. You see this section, this particular section is what? Common section, common records from both the tables, because this section is okay, having an intersection. This section is having an intersection with table 1 and table 2 also. Right table, all the records from the left and right hand side table and common records from both the tables. Common records from both the tables. Full order join, both the all the records from both the tables. Okay, all the records from both the tables. That is what they are saying. Insert the missing part in the join clause to join the table orders and customers using the customer ID field. Both the tables has the relationship between the two tables. From select star from orders left join customers on table 1 dot common column is equals to table 2 dot common columns. What is that? Orders dot customer ID equal to, okay, from table, okay, table 1 dot common column is equals to table 2 dot common columns. That is what? Customers dot customer ID. Customers dot customer ID is the common column now. If you see here, customer ID is common column, right? Orders and customers. So orders and customers dot customer ID. Perfect. See, exercise 2 you can do, exercise 3 you can do here. This is all practice you can do, guys. This is all practice you can do. Next is what? Inner join common columns from both the tables. Okay. Inner join keyword select records that have matching values in both the tables. Okay. So first trace out which column is common in both the tables. First find out that. So which column is common in both the tables? Category ID. Category ID, category ID. This is the common column in both the tables. Right now, I'll make a join, okay, between these products and categories table on top of category ID. Okay, we will join the products tables with categories table by using the category ID field from both the tables. So see here, this is having records as 1, 1, 2. This is having records as 1, 2, 3. The data is also similar only. So now I'll go ahead. I'll say product ID, product name, category name from products, inner join. Okay, table 2. This is table 1. This is table 2. From table 1, inner join, table 2 on products.category ID equal to categories.category ID. Okay. what I'm doing here, I'm making an inner join on top of these two columns. Okay, and what I'll get common records. Inner join gives the common records. If I say here try to yourself, run the sequence query. See, this is the common records, okay, that we have got from both the tables when we have joined on category ID column. See, these tables are very big actually. These tables are not having only three records. Just for sample purposes, to show the common columns, to show the columns present in the table, they have given like this three records. But this table is having actually lot of records. See how many records this table is having. Product table. The product table is not having only 3 records. It is having actually lot of records. See, this is product tables. Now select star from table name. See how many records it is having. Just for our reference to this way. This is the syntax. Okay. Select this one, this one, this one. What is this product ID? This is, we are getting this product ID from products table, product name from products table, category name from category table. Okay, this is the table name dot column name, table name dot column name, table name dot column name. From products inner join to table 1, table 2 on table 1 dot common column is equal to table 2 dot common column. Okay guys, is that clear? Joining 3 tables, we can join 3 tables also. How? See, orders dot order ID, customers dot customer name. Okay, different columns we are fetching in select. Different columns we are fetching in select from. Okay, this is one table they are considering. From orders, table name, inner join, table 2 on table 1 dot common column is equal to table 2 dot common columns. Okay, this is one join has happened between these 2 tables, orders and customers. Again inner join shippers. This is one more table. Okay, we can fetch the data from multiple tables also in joins. Okay, in joins we can fetch the data from multiple tables also, like two tables is very basic. We can go with 3 tables. Okay, we can go with 4 tables also, and go with 5 tables also. We can go with 6 tables also. We can go with 7 tables also. We can go with 8 tables also. It purely depends. See how here we are joining 3 tables. Table 1, table 2, table 3. Table 1, inner join, table 2, again inner join, table 3. Okay, if I say here, try it yourself. If I say here, try it yourself, run the SQL query. See, 3 tables I'm joining. Orders 1 table, customer 2nd table, shipper 3rd table, and I'm getting the result set for all the 3 tables. For all the 3 tables. That's what I'm trying to say here. Do these exercises, guys. Do these exercises as an assignment. Okay. No. Manju, it is not possible. No way possible. If you are doing it without common columns, you will get some wrong results. That is absolutely not possible. Okay, maybe your query will get executed. Okay, but you will not get the expected output, expected result. Next is what we are having, left join. Left join keyword returns all the records from left hand side table, that is table 1, and the matching records from the right side table. The result is 0 records. The result is 0 records from the right side if there is no match. If there is no match, see here, select a column from table, left join table 2. Same guys, syntax is same. See here, syntax is same only. Okay, see how we are having here from table 1 inner join table 2. Correct na? These are the columns what we want. We are keeping in the select. These are all the columns what we want. We are keeping in the select. From table 1 inner join table 2 on table 1 dot common column is equals to table 2 dot common columns. Table 1 dot common column is equals to, okay, table 2 dot common column. This is what inner join na. How should be the left join, you know? Same carbon copy, only you have to mention here left join. That's it. You can write in uppercase, lowercase, doesn't matter. Left join. Same you can write here for right join also. The syntaxes are not different for every join. Only these keywords gets changed. Only this is getting changed. Only this will get changed accordingly. Accordingly, the join you are using. This one will get changed. Only this is getting changed. Notice here, but rest of the things are the same only. For all the joins, only this is getting changed. Everywhere you see inner join, left join, right join. Then next is what? Full join. Next is what? If I say here, full join. I'll say here, cross join. That's it. Only this is getting changed. Rest of all these things are same only. The columns what you want you have to mention accordingly as per your requirement, and the joining column which columns are common among the two tables, that also you have to check it carefully. See guys, left join. Okay, fine. So if you see these two tables, customers tables and orders tables, okay, customers and orders table, what is the common column among these two tables? Who can tell me? See the columns and tell me which column is common in these two tables. Which column is common among these two tables? Please, I need the response. I'm waiting for it. See the columns between these two tables and tell me which is the common column. Guys, can I get the response? Put it in the chat. Put it in the chat. Customer ID. Very good. Customer ID is the common column. Customer ID is the common column that we are having. Okay, fine. See, customer ID, customer ID, right? And here see what data we are having 1, 2, 3. Here we are having data 2, 3, 77. So this orders table is not having only 3 records. Again, I am telling it is having lot of records. Just for our understanding purposes, it is giving these 3 records here. Left join, see what it is doing. Whatever the columns you want, you can put in the select statement from both the tables. From customer table, left join, orders table, left table, right table, joining on top of a customer ID column, order by customers dot customer name. So we want the data to be presented accordingly as per the customer's name. Say here run SQL. This is what the okay customer name and order ID we are getting. Customer name and order ID we are getting. Okay, fine. Right join, same right join. Only this one will get changed. Rest of the things are same only for right join. All the records from the right hand side table and common records from both the tables. Taking same orders table and employees table. Orders and employees, and here the common column between these two is employee ID. Employee ID here in this table, employee ID here in this table. 738123 something like this. Right join. Okay, only this much will get changed. Only this much will get changed. Rest of the things are same. If you understand, guys, joins are very easy. Trust me. Now it is giving right join. So it will give all the records from the right hand side table and matching records from both the tables. Okay. See, the database is having these many tables: customers, categories, employees, order details, orders, products, shippers, suppliers. Here it has given the records also. Customers table is having 91 records. Categories table is having 8 records. Employees is having 10 records. Order details is having 518 records. All the different tables with different number of records they have mentioned here. So if we are seeing here, okay, like orders table is having 3 records, then that is wrong. Actually, orders table is having 196 records. See, orders table is having 196 records. Don't be in an assumption that the orders table is having only 3 records. Just for us to understand what are the different columns we are having, and what is the common columns, to show that it is just giving some sample 3-4 records here. Guys, is that clear? Yes or no? All right. Full join, same. Full outer join, keyword return all records when there is a match. Okay, in left table and right table. Okay, you can write full outer join or you can write just full join. This is also fine, or else this is also fine. Only mention full join. You can write okay full join like this also you can write, or else full outer join like this also you can write. Both ways it is fine. It is not a problem. Okay. Fine. Rest of the query will be same. Rest of the query will be same as it is. No change. Only this will get changed accordingly what join you are using. See here now. Full auto join can potentially return very large result sets. Okay, what it is saying? It can potentially return very large result sets. Why? Because full auto join is going to give all the records from first table and second table. It will give you all the records from first table and second table. See here, this is one table customers. This is another table orders. Customers and orders. So customers table, orders table. What is a common record, common column? The common column is customer ID. Customer ID is common column. So we'll write a SQL query wherein K full outer join will join on top of customer ID. Okay, I'm joining on top of a customer ID. Okay, order by customers dot customer name. Fine. I want the data to be presented in ascending order for the customers. Like, first the customers with alphabet A, the customers whose name start with A, they will come first, then B, then C, like this. Okay. So if I go here, okay, here they have not given try it yourself. These tables we are not having. We are not having these tables, customers table, orders table. That's why we are not writing here in our SSMS. If we are having the tables, then we can write it down in SSMS also. Okay, fine guys, is that clear? Next is what? Self join. Self join, I think cross join only. Self join is a regular join, but the table is joined with itself. The table will join to itself. Example, select columns, whatever you want, mention in select statement from table 1. Okay, alias T1. Again, table 1, alias T2. Okay, what I'm saying here, table 1, T1. This is alias of the table. We have seen aliases yesterday, right? Again, second alias, where condition. If you see here, this is one table called customers. Customers SQL self join example. Customer name as customer name 1, customer name as customer name 2. So what we are doing here, we are calling a dot customer name. Who is A here? A is the first alias of customers table and B is the second alias of customers table only. B is second alias of customers table. A is first alias of customers table. Okay. So see what I'm doing here now. A dot customer name as customer name 1, customer name 2 and city, where A dot customer ID not equal to B dot customer ID. Okay, A where condition we are writing, where clause we are writing. Okay, within the table for the table data, I'm saying customer ID not equal to B dot customer ID and A dot city equal to B dot city, order by A dot city. I'll say here, try it yourself. I'll say here run SQL. Run SQL. See, this is the result set where I'm getting here. Okay, different customers, customer name 1, customer name 2 with their city. Okay, the mostly used join conditions. The mostly used joint condition is 3 only. 3 joint conditions will use mostly will use, not 3, 2 only we use mostly. If I say here, the mostly used joint condition, okay, the mostly used joints are inner joint and left joint. These are the mostly used joints. Fine, guys, is that clear? The mostly used joints are inner joint and left joint. That's it. Okay. Right joint, full joint, cross joint. This is a very rarely used joints. We use only these two types of joints. Sometimes, sometimes very rare. Sometimes we'll use right joint. Very rare, very rare. But you should know all the joints, guys. This is very important. I am telling. This is very important. In interviews, this is expected. Very much expected. Okay, fine. So this is what all about the joints, guys. Okay, SQL joints, inner joint, left joint, right joint, full joint, cross joint, self joint. Okay, and you can write the joints. Okay, only if you know what are the common columns between the tables. Okay, only if you know what are the common columns between the tables, then only you can write a joins, write a SQL join queries. Okay, if you don't know the common columns, if you don't know the common columns, then first you have to get this information from your project seniors or project architects, okay, or project team lead, etc. Don't give a wrong joins. You will get the wrong results and it will be very severe problem in the projects. Next is what union. What is union operator? Union operator is used to combine the result set of two or more select statements. Combine the result set from two or more select statements. Every select statement within the union must have the same number of columns. The columns must have also similar data types. The columns in every select statement must also be in the same order. That is also very important. See here, this is our first select statement. If you are writing here some 4 columns from one table, then in the select statement also you should write 4 columns only. Then only union will work. What is union and union all? See here, union operator, operator selects only distinct values by default. To allow duplicate values, we use union all. Union will give only the unique records. Union all will give the duplicate records from the tables. Example here, see, this is one table customers, this is another table suppliers. So what you want from these two tables, you are mentioning here. See, city, select the city column from customers table, city column from suppliers table. City. You are having one column here, then you should write one column here also. You cannot say I'll write two columns here and I will write one column here, then it will not work. Number of columns should be same. These points are very important. Must have same number of columns. The columns must have similar data types. Okay. And columns in every select statement must also be in the same order. Okay. City. This is from customers table. This is from supplier table. In between, I am writing union all. It will give me the result now. Okay. Whatever it is giving me. So the city column we are getting from customers table now. The city columns data we are getting from suppliers tables also. We are getting from customers tables. We are getting from supplier tables also. This is what how it is. Union. Group by. Okay, why group by we use? Group by statement groups rows that have the same values into summary rows, like find the number of customers in the each country. What it is saying, find the number of customers in each country. So see here, what is the syntax for group by? Select columns whatever you want from table name, where condition, group by. Where condition you want, you can write it. If you don't want, you cannot write it. It's your choice. Group by, order by. Order by is also your choice. You want to write, you can write it, or else you can't. You can ignore. But to be like, if you want the perfect query to be right, then these are all the different operators that we use accordingly. Okay, fine. So if I go down here, this is the table. Which table it is considering? It is considering customers table, right? It is considering customers table. Fine. So in customers table, we are having multiple columns: customer ID, customer name, contact name, address, city, etc. How it is writing? See, select count of customer ID, country from customers, group by country. What it is doing? This is one column customer ID. Okay. What it is been asked, total number of customers he want country wise. Country wise, how many customers are there? Germany, how many customers are there? Norway, how many customers are there? France, how many customers are there? Like this. Okay. Customer ID of count and country. And when you are using count aggregate function in your select statement, then compulsorily you have to use group by for the next column what you are keeping in your select. Okay, this is one column, this is another column, correct? Now this column we are using count function, this is aggregate function. So if this for this column, if we are using aggregate function, and for this column we are not using any, then this column we have to use group by compulsorily if we are using aggregate function. If you are using aggregate function in our select statement, then compulsorily we have to use group by for the other columns which we are not considering any aggregate function. So run SQL query. See here now it is giving me very nice picture. Okay, see, just hold on. Okay, for country Argentina, we are having 3 customers. For Austria, 2 customers. For Belgium, 2 customers. Brazil, 9. Canada, 3. Denmark, 2. Finland, 2. France, 11. So country wise, it is giving us the customer count. Ireland, Italy, Mexico, France, Norway, Poland, Portugal, Spain, Sweden, Switzerland, UK, USA, Venezuela. So country-wise, it is giving you the count of the customers for this query what we have written. Okay. Having clause. Having clause was added to SQL because the where keyword cannot be used with aggregate functions. That's true. Where we cannot use it with aggregate functions. No. Manju, record means the result set what you are getting. How come you understand record and columns? No. See here, this is what record. This is one record. This is another 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 record. This is another. These are called records. And the one what we are writing is called columns. This is a column. Country is one column. Okay. If you want, you can give as alias. Okay. I'll say here customers count. See here, I'll get on the top now. I'm not sure whether it will support or not. Yeah, see, customer counts. This is a column. This is a column. Is that clear, Manju? What is this? Share some interview question and second material. What is the second material? Right now, we are discussing all these SQL queries in the same material only. What we are having right from the first class, this material only. For the second material, that is, we are having topics. Okay, Synapse Analytics and Stream Analytics. That I'll give the material later, not now. I'll not give the material in advance. First, I will show, I'll explain, I'll go through, I'll show you all the labs, then I'll give the material. Is that clear? No, one more material I'm having. Okay, if I give you the material, can you understand by yourself? Can you do the labs by yourself? No, right? So there is no use of giving the second material without explaining, without showing the labs and everything. Correct? Yes or no? All right, fine. So see, what is the syntax for having clause? Select so and so columns from so and so tables where condition group by. Yeah. Exactly, you have group by, having by, and order by. Group by, have by. Where group by, having, and order by. Okay, this is one table called customers. This is a table called customers. Okay, and then having. How will write having? See, select count of customer ID country from customers group by country, having count of customers ID greater than 5. So what I'm saying here now, I okay, for the customers, I want all the data of the customers country wise. I want all the data of the customers country wise, and I want the countries where the customer count is at least greater than 5. So for such conditions, for such requirements, for such fulfillments, we'll use having clause. we'll use having clause. Okay, is it clear, guys, what I'm trying to say? Is that clear what I'm trying to say? I want all the customers counts. I want all the customers count country wise, and I want the customer counts only, okay, for the countries where the customer count is greater than 5. Getting? Fine. That is what I am saying here. See now, if I say a run SQL query, I'll get all the customer counts country wise, and the countries which is having the customer count greater than 5, only that countries it is showing here now. Where the customer counts are greater than 5, only that countries it is showing here. If I say here greater than 10, if I say here greater than 10, then 9, Brazil will also go, UK will also go, okay, France, Germany and USA will left over. See now, France, Germany and USA will left over because I've given here greater than 10. 11, 11, 13 is greater than 10. So this is what having clause. Okay. What it get? Exist. Exist operator is used to test for the existence of any record in a subquery. Okay. Example, this is one table. Products. This is another table, suppliers. Okay. And I'm saying here, select supplier name from suppliers table where exist product names from products table, and then I'm giving a join condition here where products dot supplier ID equal to suppliers dot supplier ID and price less than 20. If this condition is meeting, if this condition met, if this condition met, he wants product names from products table where the price of the products is less than 20. If such products exist, then show me what are the suppliers who are selling these products with price less than 20. He wants the product's name whose price is less than 20, and if it is there, the products there with less than 20 price, then that supplier names we want. In that case, we use exists operator. Who are the suppliers? These are the suppliers. Is that clear? So these are the suppliers who are selling the products with price less than 20. Getting, guys? Is that clear? This is what how it is exists I'm talking about. Any and all, any and all operates allows you to perform a comparison between a single column value and a range of the other values. Okay, something like this. Okay, select, insert into select case, SQL case. Okay, I don't think so it is important. Okay, up to here it is fine. Okay, from here, from select to up to here, this is sufficient. These operators are not required. Store procedures, functions and all that we'll discuss separately. Up to here, these are all important and very frequently used SQL operators, guys. Up to here, up to exist, that is sufficient, I believe. Not required, I have not seen. Yeah, case statement is needed. I'll explain case statement in the upcoming classes. Case statement is in the upcoming classes that I'll explain. Up to exist, if you are thorough, then this is sufficient for you for your SQL journey. For your SQL journey, this will be sufficient for you. Okay, store procedures, functions, creation of the database, deleting database, restoring the databases, taking the backups of the databases, writing the SQL queries for stored procedures, functions, all these things, common table expressions and all. This will discuss in the Monday's class. In Monday's class, this will discuss. Fine. All right. Still, many topics are there in SQL that we'll discuss in Monday's class. Monday. Tomorrow is holiday. We'll connect again on Monday. Yes, Mitrunjay, there are many things, ma.